Alright, welcome back. I'm going to try something a little bit different here. I've increased the quality of the recording to high. We're going to see how this turns out. But today we're going to be doing some sheet metal work. In particular, we're going to be doing an electrical enclosure panel. I'm going to pretty much recreate this. Well, not pretty much. We are going to recreate this enclosure and then also create and derive the dimensions for the back panel off of the electrical enclosure. So if the electrical enclosure ever changes or these hole spacings change, the back panel will also update as well. So let's get started. You can see that I've already gone through and I've created in the parameters all of the variables that I need for this. So we're just going to go ahead and recreate starting from scratch. So I'm going to go up to File, and we're going to go New, BVAN Sheet Metal, come up to the f of x, the parameters, scroll down, and we're going to do Add Numeric. And I'm going to go in ENC for enclosure length. I'm going to make that 36 inches. Add another numeric, ENC width. We're going to make that 24. ENC depth. Going to make that 6 inches. So now we've got the length, width, and the depth. So we've actually got the box. We could actually create the first surface with that. But we're going to go ahead and add all of the variables as much as possible, as much as that we know right off the top of our head. So I'm going to go ahead and include the back panel length, and we're going to use the variable that we've already created for the enclosure length, and we're going to say that's minus 2 inches because our back panel needs to be able to fit down inside of the enclosure and the return lips that are existing. So let's go back panel width, enclosure width minus 2, and as always you can always click on the arrow, get the list parameters and look for the enclosure width and then just put in minus 2 inches. Next thing I'm going to do is the back panel hole horizontal lock, horizontal location, so I put H lock, that's what I typically use. Offset. And again, we could put a variable in here. I'm just going to do this very simplistically. Instead of putting in the formula, I'm just going to put in 1 inch. Let's go back. Panel, hole, V-lock for vertical location offset. And we're going to make that 1.5 just to make it different. Let's go PEM standoff hole diameter, and that's going to be the hole diameter that would be either laser cut, water jet, or drilled, or plasma cut, so that you can mount the back panel to the electrical enclosure, and that's 0.213. We're going to go return flange width. That's 1 inch, and these will make more sense. It's just the return flange for the seal for the door. Return flange depth. And what I'm going to do is have you guys see if you can recreate not only this, but also create the door itself to fit down inside of this. I'll see if you guys can come up with it on your own, and if not, we can walk it through. But a few of these things that we want to export and make sure that they're available for the back panel is this back panel length. So we come across here, we're going to export that, and that. We don't need the PEM standoff hole diameter. That is only going to be inclusive to the enclosure itself. So we can say done there, and we can start our sketch. We are in the sketch tab. I'm going to go 2-point center rectangle based off of the origin as always, and we're going to put in enclosure width, and you can see how it turned from red to black, saying that it's accepting that. I'm going to hit tab, and I'm going to put in ENC length. It turns to black. It's accepting it. Hit tab again, and we are good. So now we hit enter, and now we've got everything's black. So black is happy. It's fully constrained. It can't be moved anywhere. So the next thing I'm going to do is come up to the sheet metal tab, click on it. Let's go ahead and set our sheet metal defaults. We're going to make this 14 gauge cold rolled steel. Apply that. Hit cancel. Still underneath of the sheet metal, we're going to go to face. It should automatically highlight the rectangle that we just created, and it's got 14 gauge sheet metal. So we'll apply that. Hit cancel. Now we need to start the return flanges. So we've just got the back panel, not the back panel, but the actual back of the electrical enclosure. So we're going to be underneath the sheet metal tab again. We're going to go to flange, and I'm going to go ahead and highlight. This is the length of the flanges coming out. So I'm going to highlight the one, go to list parameters, and we're going to go enclosure depth. And I'm going to come back up here to edges. I'm going to select on the edges here. I'm going to pick on the back side. And I'm going to flip these so that they're facing towards us. That always puts it away from you. But I am going to flip it the opposite direction to make sure that our depth stays at 6 inches at all times. So I am going to, what I did is I just flipped that by the height extents. There's this little button right here. It says flip direction, and it flipped it to the opposite direction. So again, you can see that, let's make sure, yeah, we can flip that. So now it's coming out towards us. That's the way I want it to be. And I'm going to come over here to corner, make sure that it's tear. You don't have to use tear. Some people use the little round. Some use square, and it's the relief in the corner is what it's talking about. So I could do round, and you can see how it rounds it out. Typically what I use is tear. That's what we always used up at CNT. The one thing is you can see this gap in between here is fairly large. The gap size, if you hover over the top of it, it's using the material thickness for the gap. I want to close that up. We can do pretty darn close, and then hit apply. And now we have our flanges with our seams that are really nice and tight, so they're easy to weld. I'm going to hit M for measure just to verify that the overall depth is 6 inches. So I clicked on the very outside surface to the very outside surface. It is 6 inches. We're good to go. So now we can create the return flanges for the door face. So come back up to sheet metal, flange, and this time I'm going to highlight enclosure depth, click on list parameters, and there's return flange. We want return flange width. I'm going to go ahead and select the edges, which are the outside edges. Need to flip it again, so come back over here, flip it. We're going to select the outside edge. Make sure that you're picking on the outside edges, not the inside, but the outside. Come to the bottom. And now we need to close up because we want this to be a watertight seal, so we want to close it up as much as possible so that it's easy to weld. Again, we're tearing it. I'm going to put in 0.01, apply. So now we've got our return flange for our gasket to adhere to, and now we're going to return the flange one more time as a typical enclosure would have is a little return flange, just to make sure that the water stays out. So I highlighted over the top of the depth of the return flange. I'm going to go into list parameters, and this time I want to click on return flange depth and pick on, oh, got to come up here, pick on the edges, pick on that one, just wander around the outside perimeter. Pick on the, make sure you're consistent. Don't pick the opposite edge that you've started with. Don't pick on the top. We've been picking on the bottom here. And then let's check. Yep. So our corner is on tear. We've got 1/100 of an inch of gap all the way around, and we can hit apply. So there's our enclosure. There's no penetrations, no holes or anything like that. We still need to put some holes in for our standoffs for our back plane. So I'm going to go in and pivot around using F4. I'm going to pivot around to the back side. And then I'm going to hit S for sketch, sketch on the back plane. And I'm going to come up here to construction line, and I'm going to do a 2-point rectangle. So I'm going to click on this because you can see the little dot in the middle of the rectangle. I'm going to click on the origin point and expand that out. And now I can put some dimensions to this, hit D for dimension, pull that off, go to list parameters, and I'm going to look for back plane or back panel width. And then I'm going to click on the vertical line, list the back panel length, and then I'm going to deselect the construction function, and I'm going to come up here to circle and expand that out. Now if you forgot to deselect the construction function, like let's say we've got it as a construction, we need to change that so that it's a solid line. So I'm going to come back up here and just click it, and now you can see that it's off. So hit D for dimension, pick on the circle, pull it off to the side, list parameters, and we want to find PEM standoff hole diameter. Perfect. So now what I could do is I could actually create another. Yeah, let's do that. So I'm going to come back up here to 2-point center rectangle. I'm going to do a construction line again, a construction function again. Just expand that out. Let's put a dimension to it from this horizontal line to this horizontal line. And I'm going to look for the parameter of, should be, back panel hole V-lock. So now that one's in there, and then we're going to hit D for dimension again, click on the vertical line, click on the vertical line, pull that off, list parameters, back panel hole H-lock. So what you're seeing here on the outside dashed line is the actual back panel width and length, and then this internal one is just kind of a place marker for where these holes are going to be placed, and I've offset it off of the back panel. Are variables that we set up in the parameters, and now we can take our circle, grab a hold of the center of it, and slide it over to the very end point, and you'll see that little green dot in the center saying that it's fully constrained, and then it turns black. So I'm going to go ahead and I can hit Shift Control C and place more circles, or you can come up here to the little circle function and click on the icon, but I use Control Shift C again because I'm a keyboard junkie, and you can see that I've got the construction function still initiated. We're going to go through, hit escape, and I'm going to select on each one of these circles, come up here to the construction function, deselect it, and you can see how it turns it to the solid line. And then we can come up here to the constraints, or you can hit the shortcut. As you can see in their description there, it says equal. You can hit in the parentheses, it tells you what your shortcut key command is, and it's the equals sign. So I'm going to click on the keyboard key equals, and I'm going to zoom up so that I can see the circle here. Click on that one, click on that one, click that one, to this one, to this one, to this one. So now with that function of equals, the constraint of equals, if I ever change this one to, I'm going to copy that out, to 0.5, all of those are going to change. I'm going to undo that. We don't want it to be ½ inch. So I'm going to grab a hold of the center of the circle, slide it over until I see my solid green little dot that turns the circle to black, saying that it's fully constrained. Move these down here so that I can see them. Middle mouse button to move down. Go to the center of the circle, pull this down, and snap it to the end point there. And same thing over here, center to the end point. Okay, everything is black, solid black that needs to be, which is our circles for the PEM standoffs. So now I can hit either E for extrude, or I can come up to 3D model and extrude. So I'm going to hit E for extrude. And it asks me to select the profiles that I want to extrude. And you can see how that it's extruding a solid out towards us. I want to switch that to from the join or extrude out to a cut, and it's cutting the right direction. But I want to, instead of going through all, just in case our flanges or anything else it might interfere with and it might cut out, I'm going to use the to function. This is the distance that it's going to cut to. So I'm going to hold down on F4, pivot around to the inside of the electrical enclosure, and pick on the opposite surface so that it's only cutting through the material thickness itself. Now I could have done, another thing that I could have done is actually put in a length measurement based off of the variable up in our parameters of the thickness, but I'd rather just use the opposite face that we're going to. So now I can click on the profile again and come over and select the rest of our holes. And we're cutting all the way through the material and everything looks good, so let's select OK. So now we have our enclosure with our PEM stud standoff holes that can be press fit into the back pan or into the enclosure. So I'm going to go ahead and save that. And we're going to call this enclosure box. And you don't have to put the underscore. The only reason why I did that is because this other one already exists, and I don't want to call it the same thing, so I just named it the same thing, except for it's got the underscores underneath of it. So let's come back over here, make sure that we're completely finished. Let's go into File, go to iProperties, go to Project. In the description, I'm going to go equals, because we're going to dry as much information as possible, so then we're reducing the amount of human error of possibly entering in some incorrect information. So I'm going to do this, and I'm going to say that it's a sheet, comma, with our bracket there, we're going to put in sheet metal rule, close it, comma, bracket again, we're going to go material, comma, and then appearance. Tab down, revision number. Since this is new, I'm just going to leave it as a dash. You could put in your project number, you could put in a bunch of information in here. You can also add to the custom if we needed to. We're not going to change that. We're going to leave it exactly the way that it is. Go back to project, and let's apply it just to make sure that everything looks good in our description. Yes, it's 14 gauge, it's steel, it's mild, it's semi-polished, and we're going to change that eventually. Go ahead and close. And let's just check this. Let's go to the Create Flat Pattern. No errors, that's a good thing. That means that nothing's going to crash when they fold this up. The one thing that you do have to keep in mind is who you're going to have, or who you're going to outsource this to, or if you're doing it, do they have a gooseneck? Is it going to crash into the head of the press? A lot of different variables that you need to keep in mind. But for the most part, it's saying, hey, I'm completely happy with this. Everything should fold up just fine. It does do a little bit of a check on it, but we're going to go back to the right click and go back to the folded part. I'm going to go back into the parameters, scroll down. We're going to get rid of the length, and we're going to get rid of the width. Say done. And I'm going to go back to the flat pattern. I'm going to hit S for sketch, pick on that surface. Yeah, you can't do anything on this, is what it's telling you. I'm going to go ahead and put a dimension from here to here. Yep, accept it. It's saying you can't change these dimensions. Do you still want to do it? It'll be a reference dimension. Yes, we do. We want to accept those. So I'm going to come back into the parameters, and I'm going to change this. Whatever the longest one is, I'm going to put in length. And I'm going to put in width, and then I'm going to export both of those and say done. So now when we go to our drawing, it'll show up all of that information, the length, the width, the thickness, the description, so on and so forth. So I'm going to finish that sketch, get that out of there, right click and go back to the folded part. Save it one more time so that we don't lose anything that we had. So I just did an Alt F and then S instead of having to come up here and do a save, and so it's just way quicker to do Alt F S. And even you can see how it has a little bit of a lag behind you. It's still going to save it. You can also come up here to the little save button too, but that's just habits that I've had for a long time. Alt F S. Okay, so let's make the back panel for the enclosure now. So I'm going to go File. Let's go New. Let's go to BVan Sheet Metal again. And right now it automatically comes in. So I set up these templates, like the sheet metal templates, so that it automatically starts out with a sketch. You can also see up in the parameters it starts out with a bunch of information like that length and width that we're constantly removing. We can change those template files if you prefer not to have it start out in a sketch and do this, that, or the other thing. There's tons of things that you can change in these. So I'm going to go ahead and right click, Finish 2D Sketch. And what I want to do, the reason why I finish that sketch is I'm going to come up to 3D Model. I'm going to derive, or what that means is I'm going to pull the information from the existing enclosure that we just did. So let's go to Training and then our electrical underscore enclosure box. And it says, okay, what all do you want to pull into this part file? Well, I don't want the solid body. The only thing that I want is the parameters out of that existing file. So I'm going to expand the user parameters, and I'm going to see, okay, yeah, these are available to me because I checked those export parameters, and they are available, and we can use it. The one thing that we won't need on this is the thickness of the enclosure, because we're going to make the thickness of the back panel slightly different. So we can select OK, wait for that information to load, and then we can come back in and into our sketch, hit S for sketch, pick on the plane, click on 2-point center rectangle, and we are going to just go ahead and place it. So left pick, and then I'm going to hit D for dimension, pull the dimension down, click on the list parameters, and then back panel width, check that. Use the middle mouse button to scroll out, hit D for dimension, go into list parameters again. Let's go back panel length, select that, go to sheet metal, set up our sheet metal defaults. I'm going to change this to, let's go with 11 gauge cold rolled steel. Apply it, hit cancel. Underneath of the sheet metal tab, we're going to go to face. Select the face, and then just hit apply. Double click your middle mouse button to get it to zoom out to full screen, and then let's put our return flanges in on our back panel. So click on the sheet metal tab, click on flange, highlight the 1-inch, list parameters, and let's see if I've got a back panel. Don't know if I put a back panel depth in this or not. It doesn't appear that I did. So let's hit escape, come back to the parameters, and while we're inside of the parameters, I'm going to go ahead and delete the length and the width. And what I could do instead of deleting the width is I could rename this to back panel FLG for flange depth. And we are going to say that it is 0.5 deep. Select that, come back, make sure that you're underneath your sheet metal tab, hit flange, highlight the 1-inch, go to your list parameters, and there it is, back panel flange depth. Come back up to the edges, select your edges, pick on this first one. Doesn't go the direction that I want it to, so I'm going to pick the opposite direction. Pick on that all the way around again. Make sure that it's all on the same edge that you started with. So it's the edge closest to us that I went around and picked on. If you accidentally pick on the opposite edge, just need to deselect it with Control and then click, and then select the right one. You can see again in the corners, and this is something that we could set up in the template files again. These corners are way too wide. It goes off of the thickness variable. I'm going to come into corner, and I'm going to close this gap up to 0.01. Say apply. And now we have the start of our back panel. So let's click on the view cube to the front view. Go to 3D model. And let's start setting up our holes, our clearance holes, for the screws for the standoff. So I'm going to show you here. I've already gone to McMaster-Carr, and I've already found a standoff that's a 1/2 inch deep, and it's for a 632 screw, and we can screw it through the back side too. So let's go, since we know that it's a 632, I'm going to go ahead and just randomly place. So we don't want this to be a tapped hole. We want it to be a clearance hole. Again, this is just a standard simple hole. You can size it to whatever you want it to be. Clearance hole is good for all or a majority of the fasteners that exist, and then you've got a tapped hole and a pipe thread hole, and then all these other seat features here. But we're going to go with a clearance hole. I'm going to say that it's a hex head bolt, and we are going. Oh, I'm sorry. We're going to say that it is socket head cap screw. Let's see if that gives us, yeah, it gives us a number 6. And we're going to go with a loose fit, which is pretty standard for sizing a hole. It's still fairly tight. So I'm going to go ahead and place 4 of these. And then it's saying, okay, to surface. I could go all the way through. There's no reason why I can't go all the way through on this one. There's no other features that it might be cutting through. So I'm just going to say through all. So you can see here you can change that. You can override the clearance hole size. I'm not going to. I just want it to be a loose hole fit for a number 6. And now I'm going to go to sketch. First thing I'm going to do is come up to the construction feature. Come over to rectangle, and I am going to create a construction rectangle so that I can snap my center holes to. So I'm going to hit escape to get out of the rectangle function. I'm going to go ahead and just slide these over and connect these since I'm here. So wait until you see the little green dot letting you know that it's fully constrained to that rectangle. So you can see that we can adjust that size. It's based off of the origin point, so there's always going to center these holes. So now I'm going to hit D for dimension. Make sure that I'm picking on the outside of the panel. Go ahead and place my dimension, list parameters, and I want back panel hole H-lock offset. Pick on the top horizontal line, pick on the horizontal line of the center line of the hole. List parameters, and then this one we want to do hole V-lock offset. So now we're fully constrained. You can see everything is nice and happy, nothing's green, everything is black. Yes, the holes are red, but that's just how they are. That's how they select that it is fully constrained. So now we can select OK, and we've got our holes for our standoffs. So I'm going to go ahead and change this. Let's make it like the other one. Yeah, let's make it smooth yellow. It's easy to see. Go ahead and save this to elect. What did I say on the other one? I said elect underscore elect underscore enclosure back panel. Save it. Alright, so we have our 2 parts. Oh, before we go too far, let's go ahead and go back to the sheet metal tab, create the flat pattern, and then I'm going to hit S for sketch. Yes, you can't edit this, so we're going to hit D for dimension. Go ahead and pull off our dimensions. Yep, accept it. Can't change those dimensions. They're going to be reference dimensions. Accept it again. Come into your parameters. Change the D0 to length. Make sure that both of these are exportable. And we're going to go width, and we're good to go. So now those dimensions are available for the drawing parts list. So we can return, right click, and then go to return unfolded part. We'll save it one last time. And now let's start the assembly. So let's go to standard IAM. So I went Alt F and new, N for new. Okay, so hit P for place, track down light, training, and then we're going to put in the electrical box first, right click and place grounded at origin. Hit P for place again, and we're going to go to the electrical enclosure back panel, say open, place that. Next thing we need to do is place the PEM stud standoffs. So I'm going to go back over to McMaster-Carr from the one that I had already found. Make sure that the step file is the one that you've selected. If you're using SolidWorks, there's a SolidWorks feature there that you can use, but we're going to use the 3D step. Save that. It'll ask us where we want to save it to, if it ever does. There we go. Let's go to customer data files. Let's go to flight. Go to training. I'm going to take this and I'm going to back this out, because all we want is the part number and the file name, because it's going to use the file name for the part number. And then I'm going to minimize that. I'm going to do Control O for open, or you can go File, Open. Again, track down where you located or where you save the file to. This dialog box will open. Select on file type, and we want to go to step file. And this is the file that we just downloaded. We're going to go to open, and it'll ask you a few questions. We're going to go ahead and select the defaults that comes with Inventor for the step file conversion. Okay, so there is our standoff. It's threaded on that side, and we've got our little press fit on this side. We're going to go ahead and change a few things like the material, and let's say that it's just standard steel. Let's not do anything fancy with it. Let's change the color of it to something like satin polished, and do a Alt F/S for file save. Let's put a description in here. So Alt F and then go to iProperties, go to Project. In the description, you can see that it puts in a generic step AP203. That's just the version type of the step file. And we're going to put in standoff, comma, 6. It was a 632 by 0.5 inch steel. Let's go back here and go press fit, comma, steel. And we could take this out instead of hard entering. Again, we don't like to hard enter stuff. I don't like to, because then it just adds to the fact that you might have human error. So we're going to go equals up at the very beginning of the statement, open bracket. We're going to put in material, close it, tab, revision number. Don't really care, it's not going to show up. We don't need to do a drawing on it, so let's go apply, close that, Alt F, save for S for save, come back over to our assembly, and now we can place those PEM studs, or those PEM standoffs. So there's our file. It's an IPT file now, that because we saved it. Go ahead and open that, and let's place a few of these. Hit escape, zoom up on this, hit C for constrain, and we're going to do a face-to-face or a flush mate. That one to this one. Apply that. That one to this one. Apply that. That one to this one. So now when we go to place the first PEM standoff, they're all going to face the same direction. You'll see that here in just a second. I'm going to go into Insert, and I'm sorry again, I think I went a little too fast. So for the constraint, you can either hit C or you can come up to the Assemble and Constraint, and I'm going to go to Insert, and I'm going to pick out the outside, the side that's actually going to be pressed into the material. I'm going to press on, or I'm going to click the Insert and click the outside circle. Hit F4 to pan around so that I can see this top left hole. I'm going to make sure that I'm picking on the inside surface where that it's going to actually mate to. And you can see that it automatically places. That's one of the nice things about Inventor over SolidWorks. SolidWorks, you have to pick 3 different variables or 3 different surfaces to locate this little standoff. It's ridiculous. So let's go Apply and find out where the other ones went. And double click the middle mouse button. I have no clue where they went. There they are. If you can't find it, if you get a really complex assembly, what you can do is you can come over to your browser on any one of these, right click on it, and say Find in Window or hit the End key. So I'll go Find in Window. Oh crap, it's going right through the middle of the material there. But if you hit F4, you can pan her off to the side. So now if I click on this, I can hit G to rotate that part so that I can see the face that I want. Hit C for Constrain, go to your Insert, Constrain again, pick on the outside ring. Can't see that hole, so I'm going to hit F4, zoom up, and pick on that surface again, that circle that exists, the bolt hole circle or the press fit hole. Come back over here, hit G, click on your part, hit C for Constraint again, go to your Insert, Constraint, click on the surface that it's going to be mating to, and click on the circle, the bolt hole circle, and do it one more time, and we're done with that part. So I'm going to hit G for Rotate, C for Constrain, go to the Insert, from there to there, F4 to pivot around to see our hole, Apply, and now we've got our standoffs in our back panel. So now we need to locate our back panel itself. So I'm going to hit C for Constrain. I'm going to use that same Insert Constraint again, pick on the inside surface that the standoff is going to be mounting to, click on our standoff, apply there. So now you can, as you can imagine, this thing can pivot off of that one standoff. So I need to constrain it one more place, and it'll hold everything in place the way we want it to. So Insert, Constrain again, back side of the panel to the surface that of the standoff that it's going to be mounting to, and now we have our enclosure with a back panel and standoffs. So I'm going to save that. Electrical enclosure assembly. So now that is all saved. We can come back over to McMaster Car. We could pull a number 6 screw and some washers and put those in there as well. I'm going to have you guys go ahead and create the door. We'll have you recreate the enclosure itself, the back panel, and the door itself. So we'll start from there.